Hello everyone, this is Ahmed Mahmoud from DataMindAI. This session is part of AI Ready, Business Ready, Decision Ready series, and this is AI Ready Demo Part 4. Let us start. As you can see here, last time we were looking at the AI readiness, and what we have identified was like there are 4 sections to the AI readiness. We saw data quality and reliability. We saw governance and security, and the third one is semantics and metadata, and the fourth is going to be closed loop learning. So, in a nutshell, we are looking here AI ready data stack. So we were looking from when we load the data from the source, we ingest it using ETL pipeline, and then we are following the medallion architecture. So the data is moving from bronze, and then we are validating the data, cleaning it up, and then moving it to the silver. So the clean data is in the silver, and those who does not pass the validation rules, they will be quarantined. They will be placed in a quarantine data set so that we can look at them at a later stage. Now, today though, we are going to look at a different area of our AI readiness. So we shouldn't forget that this all exercise is for us to understand what is required to be AI ready. So just to have like a good understanding where to look and how to do your assessment for the AI readiness, and therefore when we implement AI, you will be in the right position. So today is going to be, as you can see here, the semantic model, which is going to be basically is going to be in this side, as you can see here, this side. So that's what we are going to do. Like the semantic side, the semantics. We will try to understand the context and the semantics in a much better way. So before we go to the demo, though, I want to show you very important how we are going to do it and what is the overall overview of this site. So the starter is like the curated data, as you can see here. So we have created like a customer silver layer and order silver, which means this is the cleaned up portion of our data, and also it is governed as well. So we put like governance and security on top of this one. So what we will do now, though, we will have 3 aspects for us to understand the context, because AI understand we need to put like large language models, we need to put data into them, so that for them to do some work or some action. And before we need to prepare our data, especially the LLM wouldn't understand our data, our system, or databases, what we have. So it's not clear for the LLM about our system. So we are going to give them our data, which is like, for example, the LLM wouldn't understand what this customer data is or order data. So we are going to give it to the LLM to look at this. So what we need to give to LLM to give us the better solution for our problem is like one side is like we need to give them like a data asset registry. So we need to give them that what is this asset name, like the customer or the order side, who is the owner, the sensitivity line, the lineage from where it is coming. So we need to give all this information. It's called metadata information on top of the data as well, of course, and then also we need to make sure that the context of the data. So we need to give the LM what the customer means to us and what order is all about, the definition of order when you say order, and when you say department, what do you mean, and when it is confidential, what is that confidential also means. So we need to give this too, and also we need to give like another information as well, like statistics and profiling. So, for example, how much the raw count, the distinct value, the total and average of the data. So all this stuff is going to help the language model when you provide the data together with these three elements into it. We ground the LLM on this data, the metadata, as well as the statistics and profiling and business glossary as well. So when we give it all this stuff, we call it governed meaning and rules. That's what what we are doing. So the data now, together with all of this stuff, is going to be we call it a knowledge document. Yeah. So this knowledge document will have metadata, defined lineage, and site as well. So the knowledge, then we need to mimic RAG. RAG is like RAG stands for Retrieval Augmented Generator. So it means like our data. In short, not RAG is like it's not the LLM data. The LLM doesn't understand our data. We call it this RAG, which we give it the context of one we said before. But for the LLM to understand the system we are given is, so we need to put it like in a computer understandable way, or LLM understandable way, which is numbers. So what we do is like the whole the data which we put, the knowledge base which we prepared, we need to divide them into chunks, and those chunks need to be converted to numbers, which are vector database with the vectors. So those ones will be fed into the LLM for an answer or the retriever, and then we'll have the one we need. So our solution would be, the output would be, now this LLM will not be hallucinating, because it will be grounded into a knowledge which is like our understanding as humans. Yeah? So we are giving all the information which we as humans process and interpret. So we are given all this information, and therefore the LLM will have the answer without hallucinating, and it should also be sensitive, aware, and accountable as well. So because the owners is there, the sensitivity is there, and also we have grounded our data into information which is very useful. Like we have given glossary, we have given statistical and profiling information. So that is what we are going to do. We are going to emulate this one into our script, and that is what we are going to do today. So what our script here, like as we'll start from the beginning now. So the context we are talking about, as we saw it before, this is like we will create like a tiny business glossary to emulate the glossary of the information about the organization. So that is one area we are going to build. Also, we are going to build like the metadata registry, which is who the owner, lineage, and sensitivity. And then from there, and then using the one I said, the statistics from the data, we are going to create the RAG-ready knowledge base for structures data. And then from this data, we are going to do the retrieval. We are going to emulate the retrieval, because we said, we like what the LLM is going to do. So we'll do this. We'll run a lightweight retriever demo, which is a cosine similarity. Yeah, that's what we're going to do in a nutshell. So we have these 4 tasks to do. So for task number 1, which is like before we start the task though, what we need to do is like as we do normally, we bring the path, or the path from the path library. We import the path, which can help us navigate around the folders, and to create folders, directories, and so on. Yeah. So directories or folders, one of the two. So that's what we are going to do. We are going to bring pandas, because we are going to import like cleaned silver data for customers or orders as well. But because they are in CSV files, so we need to import pandas for so that we can put it into the data frame. As you can see here, this is like the one we have been doing for the last 2-3 days. So we will create variables and create also directories if they don't exist. So so this is number one. So what we do, like we define file system path called doc path. As you can see here, we are creating make the uses. We are going to use path library to construct the path in OS independent way, because the whole idea of using this path library is to have independent of operating system like Linux or Windows. So we don't want, like if you are going to run our script in, for example, Macintosh or Macs, it shouldn't fail. Or if you run it from Linux, I'm running it now in Windows, so if I run it in Linux, it shouldn't fail as well. So that's the whole idea of bringing this path library, because it will take care of all these operating systems. So it will be cross or operating system independent way of working on. And then we are going to create, if it does not already, directory. So this is again a key part of the mkdir. It will create a directory. So we'll provide two parameters here. One is like the parent is true, which creates all missing parent directories. Yeah. If they don't exist, it will create all the missing parent directories, and also it will not going. It's not going to be to give you an error. It will prevent error if the directory already exists. So it is not going to create a directory if it already exists. It will not say, "Oh, the directory exists," and then stops working. So that's what is going to happen if you put this exists or case true. So that in short, this one guarantees that a stable and a repeatable location to store AI-ready documents. Yeah. So why does this matter for AI-ready systems? So this directory is not just a storage; it represents a knowledge-based boundary, the points where raw data, curated data, AI consumable context exists. So LLM cannot reason safely over raw tables, because we are not going to give to the LM raw data, because it's not safe to do that one. So we are going to do consumable, like cleaner data, as well as uh, governed, plus the way we described before, metadata. Also, we need to give all this metadata. So it will be AI consumable context, as it were. So the reason over document with meaning. So they reason. So the LLM, they are going to reason with documents with meanings. So we give them this way. So what is going to happen is, like in a nutshell, you have the base path, the data, and then you have the curated folder. Within the curated folder, we are going to create a knowledge base where we are going to put the data which is going to be used by LLM, or retrieve the data for future LLM work. Yeah. So for each level of the path is intentional. For example, the data is container artifact derived from data, which will be separate. The data will be separate from application code, the configuration code, or module code, whatever source code. So what we are doing is, like, by putting this folder structure, everything which derived for data will be placed here. So we are separating from other folders which are not relevant for data. So within the data itself, we are saying curated, which means clean data. This one signals that the data is validated, governed, safe for downstream use. Yeah. So it is equivalent for in the medallion architecture for silver or gold layer. And AI should never consume uncurated artifacts as well. So the knowledge base, this is the critical layer. It contains asset intelligence document, governance metadata, semantic context, and human readable and machine readable text. So these files are not, for example, raw data. They are not logs. They are not they are not prompts as well. So they are grounding text for AI, the knowledge base. So we are going to put all the ground text for AI in this knowledge base. So how is this used in RAG pipeline? So what happens is like later notebook steps write documents into this directory. Like for example, when you say doc path, the asset text, and then write text. Yeah, that's how we are going to put this. Means each governance data asset produces its own document. These documents from the retrieval corpus, they can be later embedded, indexed, searched, and audited. Yeah, so the AI ready principle illustrated. LLMs reason over documents, not databases. So the directory is where data is translated into language, governance is translated into context, and assets become knowledges. So we have this boundary. For example, without knowledge boundary, without this knowledge base, the one we're talking about, AI reads from raw data, which is not the right thing to do. But with knowledge base, AI reads curated context. Yeah. So in this knowledge base, you have explicit lineage, sensitivity, aware and grounded answers, and production ready AI. Yeah. So this is a file-based demo because the reference implementation uses file system deliberately. This is why, because no vendor locked in and fully inspectable. We are not using about databases because we don't want to be vendor locked one. So the file system will be uh, uh, it is not going to lock us anymore. So the file system is no vendor locks in, fully inspectable. Also is going to be Git friendly, easy to version and audit. In production, this path could map to AWS Gen 2, Amazon S3, Azure AI Search Source Container, vector database ingestion paths, and so on. Yeah. So doc path is the contract boundary between governed data and AI reasoning. So that is what we are going to do. From the curated data, we are going to load the customer silver, the order silver, and then we are going to. This is the glossary we are talking about. So, for example, the customer. This is the term is called customer. We are putting them in the data frame, which is a table-like structure. So one column is a term, and in that term we are adding a customer, and the definition for that customer is an individual or organization that has an active relationship with the institution and a unique customer ID. This is we are giving this information for AI. So that's what we are talking about when you say glossary. So, for example, this order, the order is a recorded transaction linked to a customer ID, representing a purchase or chargeable event. So, what is department? The department is business unit responsible for the customer relationship and data stewardship for related records, and confidential the data that must not be exposed outside must not be exposed outside approved roles. Access require auditing and policy enforcement. So these are like the terms and their definition, which we are going to feed on top of our data, this customer and the order data. So that is one area. And for example, the this here, the pandas is going to create the pandas. This is PD's pandas is going to create the data frame called glossary. Each row represents a business term, and each term has a term which is the name, the concept, and the definition. The data frame is displayed so it can be reviewed by humans, reused by pipeline, or injected into AI context. So the value here is semantic precision, not computational. Yeah. So why this matter for AI readiness organization? This glossary defines context semantics, the shared meaning that aligns humans to data to AI systems. So AI systems fail where they don't understand what words mean in your organization. This table removes this ambiguity. So, this is again the whole exercise. This whole exercise of AI ready is like to be ready, and we don't want failures in the production side. So to avoid those failures, what we need to understand is like AI. They are not like humans. We need to provide them all the information which we know, so that they can give us the right decision. So that's the whole idea, and this is the glossary is just doing that bit. So the term as semantic contract example for customer order dependent confidential. So this is part of the governance side, by the way. In the governance side, you can collect it using Purview, Purview or Collibra. This glossary terms. It's just it's very important concept over there. So it helps you to collect all the glossaries or to feed it into a system so that to explain the data there as well. So this is part of it. We are doing it here in a text in a file just to give us like understanding. But it can be done like even on this Purview and Colibra. What you do is like you can feed the glossary using a text file or CSV file and then load it into the Purview as glossary to be taken there. So this is similar to that one. So for example, this is very good example here. When you say these are not, this is very important distinction. These are not dictionary definitions. They are enterprise semantic contracts. Yeah. So they are not like a definition for like a dictionary universal. You can find it everywhere. So it is just related to specific organization as well. So, for example, customer explicitly requires an active relationship, a unique customer ID. So that's what you are looking for. And an order is explicitly is transactional, linked to a customer. So that's what we mean by it is not a dictionary, it is a semantic contract. And the AI can now reason safely about joins, counts, trends, and constraints. Yeah. And then this one, it also prevents semantic drift and hallucination. Without this glossary, for example, customer could mean if you don't put the glossary, the customer could mean prospect, alumni, supplier, or user. This is like the meaning of a customer. It depends on how to use it, on how you use it. And order also can mean request, workflow, or system event as well. So that's so if you don't put clear what you mean by customer or order, then the LLM will guess with from all this stuff. So it will hallucinate. It may say it's alumni for the customer, or it might say system event for order. So that's what we mean by hallucination. So it will guess, but with this glossary, meaning is anchored and AI responses stay consistent. Cross-team confusion disappears. So hallucination is often a semantic problem, not a model problem. So this is very important distinction. When we say LLM are hallucinating, it is because the semantic issue is not resolved, and we are not talking about the problem, model problem itself. Yeah. So it also enables governed AI responses. The term confidential introduces policy semantics, not just vocabulary. Yeah. So this enables role-based, role-aware retrieval, sensitivity filtering, and auditable AI behavior. Just by putting this confidential, it will introduce policy semantics. Yeah. So the answer using the enterprise glossary and do not expose confidential concept. Yeah. So you can give the LLM an instruction saying answer using the enterprise glossary, just like for example, and then do not expose confidential concepts, for example. Yeah. So AI will understand that this time is not going to expose your data set which has a confidential mark into it. So that is governance enforces through language. Yeah. and also machine readable and business knowledge. Because this glossary is structured, it can be embedded into a vector store. It's very important here, injected into system prompts, linked to data quality rules, and also aligned with governance tools like Purview and Colibra. So why is that when the glossary is structured? And this turns documentation into executable context, yeah, which is very important in this context. So how this glossary is used later, this glossary can be added to the AI retrieval corpus, used to validate the generated answers, combined with asset registers and queried by agents. What does customer mean here? Yeah, so that you can be queried and then you get the answer. Example, downstream rule. You must use the enterprise glossary definition when answering. So this is like you put the prompt into the or instruction for the LM. So again, if we only compare with and without glossary, the glossary have the shared meaning, stable reasoning, safe assumption, policy-aware AI, production AI as well. So that's it's very important to make these distinctions as well here. So this AI ready principle illustrates that AI readiness starts with shared meaning, not models. Yeah. So this glossary is a semantic foundation of trustworthy AI. So and then the metadata plus registry plus lineage context also include. Don't forget, includes the context, include ownership, sensitivity, and how the data set was created, which is lineage. So, for example, this is the registry. So now we are coming here to another level. We finish the glossary, and this is the registry. So we have the asset. Asset is like our data set. So the cleaned data set, which is in the silver, this is our asset, and then we are creating now again a data frame for the registry. So we are saying the owner. We say always we need to put an owner, and then we need to put the sensitivity, which is in here. The customer is confidential, and order is internal, for example, and then the lineage, which is the source from where it's coming. So this coming from customer CSV, and the other one is called from order CSV. This is like the ingest the source data, and then the transform is like, for example, remove negative amounts plus required currency. Yeah, so this is the duplicate and remove duplication, standardize country, and quarantine as well. Yeah, so that's the information, the registry information which we are having. And then when you look at it, it says, like, for example, the assets. You have two assets here. You might have a list of the assets, and then we will have the owner, the sensitivity, the source, and the transform side to it. And in here, we are creating, if you see here, we are creating a data frame called registry. Each row represents a managed data set, and each asset is described using governance critical metadata, which is asset is the name, owner is accountable, human role, sensitive is data classification, a source is lineage origin, transform is enforced data quality rules. Yeah, so we are putting this one into the registry now. So we are putting the data quality, the lineage, the data classification, also the accountability, also the owner. So the data frame is displayed so it can be inspected by humans, consumed by pipeline, injected into AI context. Again, the value is not computational; it is control. And why does it matter for AI here, for AI organization? This registry operates operational semantics, the bridge between data and decision making. And AI systems fail when they don't know what data they are using, who owns it, what rules were applied, how sensitive it is. Yeah. So the asset identity is, for example, you have two assets with a data set. These are semantic contract, they are called. Yeah. So this is a semantic contract, and they are not file name anymore. So this is the contract we are saying. So silver implies that the data is validated, cleaned, business ready. AI can now reason differently about raw with curated data, trust levels, and suitability for decisions. Without this, AI treats all tables as equal. Yeah. So the ownership is who is accountable. For example, we put like the owner from the data side, and the finance side as an owner. This introduces human responsibility into the system. Why this matters? Because AI can escalate issues. If there are problems, we need to have like escalation process, rules questions, and questions which are, for example, for the data quality, or we can go to data stewards. If there is like an update, we want to update the whole table, it might go to data owner, and so on and so forth. So it can route a question which has been asked by a user, and also explains provenance. AI without ownership is ungovernable. So the governability or accountability is very critical here. Sensitivity is who is allowed to see this data. It is confidential and internal. This enables role-aware rugs, access filtered prompts, and policy-aligned AI responses. For example, you can say summarize customer trends without exposing confidential fields. Yeah. Without this metadata, AI will overshare, as it were. So, which is very, very bad for data, and organization as well, because you might breach like rules or countries' rules as well. So a law might not allow you to do this kind of sharing, to overshare. Now, the lineage is going to be where did it come from? The source, which is customer and order CSV. This supports explainability, auditability, regulatory compliance as well. So I can now say this insight is derived from order.csv processed into order underscore silver. This sentence alone is production grade AI. Now, transformation rules, what was enforced here. So the data quality guarantees here, they tell AI what error were removed, what assumptions are safe, what anomalies were isolated. This prevents AI from trusting dirty data, amplifying errors, making unsafe recommendation. How this registry is used later, the data frame can be embedded into prompts, queried by agents, enforced in pipeline, cross-checked during inference, and then linked to purview. The example is which you can give an instruction, for example, only use assets marked silver with sensitivity less or equal to internal. So this is the instruction you give to LLM, especially during agentic AI. So to make AI more like, to do actions, or to do learn also from its own mistakes. So this instruction is very useful, and they are dependent on this registry as well. So the AI governance is, this is AI governance in one line, So without this registry, AI guesses trust. With the registry, AI knows trust, no accountability, named owner with the registry. So it is unsafe access, sensitivity aware AI you get. So black box output, explainable lineage you will get. So with the registry, the AI will be production AI. So AI ready principle illustrated that AI must understand the rules of the data, not just the data itself. So That's the key part. That's what we are talking about. It's not the data itself. We saw that the data should be um, added or augmented by given like the glossary, the registry, as well as like profiling of the data as well. So the statistics which for each data set. So the registry is a decision control plane disguised as a simple table. So it is a decision control plane. Yeah, we decide based on what is inside it. So they built a RAG-ready knowledge base, which is structured to text. Yeah. So a common mistake is dumping raw files into a vector database, which is now that is a key part here. Instead, curate a small, meaningful document with. So what you need to do is like you shouldn't when you create like a vector database, which is like the key part of AI. So don't use the raw file directly into the vector database. What you need to do is like first you need to curate it, meaning you need to do the clean up, govern it, and also if it requires transformation, do the transformation. Do that bit, and then plus that one, you need to add the definition, the key stats, the ownership, and the lineage. So, and then we will generate one text document per asset. Yeah. So that's the key part, which we need. We are taking it from this exercise. So this is like the implementation of this one. So we'll go through one by one as well here. What is happening. Um, so what we do, as you can see here, for example, let us go from here. This is like uh, we have this is a function. So this function is called asset doc. It is taking an asset name, which is customer silver, for example, yeah, and it returns a string. So the first one is like it says meta. So it is asking, it is doing the querying the registry, yeah, with the asset name, and then and we are going to go through each of them there, yeah. So so if it is a customer, so what you do is like the count low the row count. We will have like distinct customers. We have departments, sorted departments, countries sorted as well. With no and if it is order, for example, we will have the raw data. We will add this extra piece to the data here, the statistics we're talking about, and then from the registry as well, we will take the owner from the metadata from the meta. This is the meta which is coming from the registry. So we will take also the owner, and then we will take what is the sensitivity. Is it confidential, internal, public? And then from there also we'll take the source, and then from there we'll take the transform as well. So the key statistics also will be added there. So, and then we'll add those ones into a document, yeah, and then that document will be written into a folder, yeah. So that is in a nutshell. But it is good to look at what is happening, just to understand what is happening line by line. I will summarize as far as I can, but it is good to understand what is happening in this code here. Yeah. So this line, which is doing is filter the registry table, which we created before, for the requested asset name. The asset name is like it could be customer or it could be order, and then take the first matching row, the first one. If you have, it gives you like 4 or 5. So just to take the first one and then convert it into Python dictionary, yeah, to dictionary. This provides what happens is the owner, the sensitivity classification, the source system, lineage, and transformation applied. Yeah. What it matters is this is the governance control plane that AI must respect. Yeah. So from this asset, we are going to take this one, and this is the control plane. Now, compute asset-specific statistics from the actual data. So, as you can say, for customer silver, yeah, we can do is like this creates a small profile, so I can answer questions like how many customers exist, which departments are represented, which countries appear in the data, for example. Yeah, so these questions can be answered if you have these statistics into that one. So the older one as well, this enables AI to answer questions like what is the total or average order amount, what currencies are present as well. So that's so why it matters, because statistics ground AI responses and reduces hallucination. So they are not going to guess because we are giving all the information needed. Yeah. Now generate human and AI readable asset document. So for this, we return the asset and the owner, sensitivity, source, lineage, key statistics. Yeah, this turns metadata plus statistics into structured text. Now the output looks like data product passport. Yeah, it has an identity, accountability, policy classification, provenance or lineage, key metrics. Yeah, so that's what we are doing as a data product passport. It's called. Yeah. Now generate documents for every asset and write them to a disk, like the document here. We are going to have a dictionary. So from the registry asset we are going to have like the information because we call it asset, and then we are going to add to it into our file system. So iterates over every asset name in the registry and then generate it as a document with asset doc and stores it into memory and then saves it to knowledge base folder as text file. This file becomes your retrieval corpus for RAG. Yeah. So that is the one we are going to, it looks like our RAG system now. So shows the first few generated documents. I mean, in real terms, I mean, if you have a database, you don't go through this route. Of course, the principle is the same. So you might create views from the database, and then, of course, you need to have the registry, the data dictionary. But the way you add them, the way you bring them together might be separate, but the principle is the same. So you can see you can list the first few generated documents. Now, what is foundation for RAG and AI readiness? So LLM do not naturally understand what customer silver means, who owns it, whether it is confidential, what transformer applied, or what the data looks like right now. This code, what we have done is this code grounding the document that makes those answers explicit. Yeah. So what you gain is governed by design, sensitivity, and ownership become part of the AI context. Explainability, AI can cite lineage and source, reduced hallucination, stats anchor answer in reality. Safe retrieval, you can filter documents by sensitivity before answering. Portability, text files are inspectable, versionable, and easy to embed or index. Yeah. So the AI ready principle illustrated here is LLMs reason over document, not database. This cell translates governed data assets into retrievable knowledge. So when you see about how it is the control, the registry is the control plane as we're talking about. The stats is the data plane, and then the asset document is the knowledge, and then this is what we are going to look now: the retrieval, and then the retrieved one the embedded with the vector database, and then you have the LLM generation, which we feed this embedded data to LLMs for ground answers. Yeah. So in production, you can store this document in ADLS Gen 2 index them in Azure AI search. Yeah, if you work in AI search, you index them into AI search, embed them into a vector database, enforce role-based access using sensitivity field. So now the last bit here is the retrieval demo. So it's a little bit long here because the retrieval, we are mimicking the vector as well as the for example the retrieval side of it. So what we are going to do is like vectorizing it, and also we are going to do like cosine similarity, and based on that one we are going to retrieve the information. Yeah. Now we are going to use I'm trying to explain this one. Probably it might take me a bit long, but spare me because the principle is slightly long by itself, yeah, by definition. So let me just try to simplify it, yeah. So what we are doing here is like now we have the document, yeah, the knowledge base as well. The knowledge base. Let me return back to what we have done so far. So we have the curated data. We put the asset registry with all this information: asset name, owner, sensitivity, and lineage. We also have the business glossary. We defined what customer is, order is, department is, and confidential. We also did the statistics for each asset, and then row count, distinct value, totals, and average, and so on. And then all is being fed, and then we built like a knowledge base document. So this knowledge base or curated text file, as it were, then we need to split it into chunks and creating a vector out of it, or vector database out of it, and then we feed that one into LLM. So that's what we are going to do. This last part is like the vector and side to it. So let me try to explain what we are going to do here in a nutshell. So we are going to have like the document with the asset, sensitivity, and owner. Document 1, document 2, we call the corpus. We feed it into this vectorizer to create a vector. We call them tokenizer. We call token or chunk or small pieces of text, and then those small pieces we can compute the term called frequency, and then rarity corpuses and weight terms, just to make sure that the numbering will be properly near the one it is used in the real world. So, for example, the document term, it will have, this customer will have like this numbering system. Instead of the small chunks or tokens, we will have numbers, which the computers understand. Yeah. So that's what we are going to do in a nutshell. So um, and this is like when you try to compare two, for example, tokens. Yeah, they will have like they call this. We'll do like cosine similarity. So what is happening here is like in Python, we can the scalar will have a feature extraction called TF-IDF vectorizer, yeah, and then another one is cosine similarity. So we are bringing these two uh, into our system here to use it to vectorize as well as to do the cosine rule. Yeah. So I'm trying to explain these two functions. These two we brought in there. What is all about? So, for example, the text is like we have a text. Yeah, we have a text like this one. For example, our customer database is confidential. Blah, blah. That's all this text is here, and then you convert it to chunk. Yeah, chunks like confidential data, governed data. From here, just we split it into areas, into small pieces. Yeah, so these small pieces then is converted to numbers. Yeah, so this is the one. So, for example, it will represent, for example, customer database, and one of them will represent confidential data, and so on. Yeah. So this is one, and now when you try to compare them, so the two documents might be in a similar place, and then it might be separated by an angle. So the system will do this something called cosine similarity or vector similarity for this embedding, just to make sure that which one is near to the second to the second one. For example, this is, I think it is good to have by example. So if there is, like, for example, a king and a queen, so how do you know which one is or the system LLM? How does it knows which one is like a female and which one is a male? Yeah. So this kind of exercise, you would have like a vector for a king and a vector for a vector for a queen, and then you will see each one will have like a number which is associated with it, depending on the context of the king. So what king means, and then each attributes of a king will be given a number, and each attribute of the queen will be given a number, and then the angle, the difference between the two, in this case the cosine angle, will tell you whether they are the same or different. If they are the same, for example, they will be different, and then the difference will be like the context will be like female or male. Yeah. So that is like one area which I'm going to have another session based on this vector databases and how they are created and what these numbers mean. But for now, I think that is enough for this exercise. So what we are doing is we are bringing these two and TF-IDF vectorizer and cosine similarity. Yeah, we are bringing them into our system, yeah, and then we are importing them here, and then that is what we are going to look. Yeah. So what do they mean? So this one we need. Why do we need them? So computer cannot directly compare meaning in raw text. They need numbers. So TF-IDF turns each document into a vector, so you can compute similarity. Yeah? So what does this TF-IDF mean? TF-IDF is a term frequency times inverse document frequency. Yeah? Term frequency, how often a word appears in a document. For example, if you have, I don't know, appear, how many times it appears, 1, 2, 3 times, and then if confidential appears often in a document, TF is going to be high. Inverse document frequency is how rare a word is across all documents. For example, the word like there and appears everywhere, so therefore they have low IDF. Words like confidential, lineage, owner are rare, and therefore they will have high IDF. So TDF and IDF highlights words that are important to a document and downweights common fillers words. Yeah. So and then you have this cosine similarity is measures how similar two vectors are by looking at the angle between them. So cosine similarity measures how similar two vectors are, and therefore for text we care more about direction, which words are important, than raw magnitude, document length. Yeah, two documents can be very different lengths but still talk about the same topic. So cosine handles that well. Yeah, how it works, and if two vectors points in the same direction, they have similarity close to 1. If they are unrelated, similarity is around 0. If they are opposite, like rare in TF-IDF, could go negative. in the RAG mimic cosine similarity answers which document is TF-IDF fingerprint is closer to my question fingerprint. Now that is I think for these two ones. So now let us do the work itself. So first we prepare the document corpus, it's called, yeah. So and then document is a dictionary created earlier. So we created this the doc, yeah, the docs earlier by when we were doing the first part, and now the key is like asset name is customer silver, and the value is asset intelligence document, which is the text. Now, these steps extract document names, builds a list of document text. Yeah, these documents form the knowledge base that AI is allowed to reason over. Now, we can now this document, now the one we have created, yeah. So what we will do is like we will vectorize it. So we'll bring this one. The stop words will be in English, and then the vectorized fit transform, we put the corpus into it, the corpus which we have built here, which from the key and the value. So we are going to vectorize it. So TF-IDF term frequency, inverse document frequency, tokenize the text, the downway common words, emphasize distinctive terms, and X becomes a matrix where each row one asset document and each column is going to be a weight term. So this classical NLP stands in for modern embedding modules. In production RAG, this would be replaced by embedding modules in a vector database. So that's what we do. So AI search and also embeddings from Azure, from different systems. And then the vector database, it could be AI search database or other systems as well. So in real terms, in production, we are going to use different, but here, because we are going to test it just to understand what is happening, that is why we are bringing this two from Python package. Now, the retrieve is like the function here, takes a natural language query and returns the top key most relevant document. And then vectorize a query, of course, to transform them. This user question is projected into the same vector space as a document. Now, once you do that, when you compute the semantic similarity, the cosine similarity here, calculate cosine similarity between the query vector and every document vector, produces a relevant score per document. The answer is going to be now which document is closest in meaning to the question. Now rank and select top results. Zip document names with similarity scores sourced by relevant highest first, and then return top X result. Examples are here. So a full RAG pipeline has two phases. Yeah, that's the key. The other is like it is very useful, but the important one is here. So each RAG pipeline have two things. One is retrieve relevant context and generate an answer using LLM. Yeah. So this is the key part. So retrieve and generate is the key, the two phases. The notebook cell implements phase one only, like user question, and then you prepare them for the document retrieval, which is this code, and LLM generation is omitted here. We are not dealing with generation for LLM. We are not adding here the LLM. So we are the retrieval side. Like if you have a database, as I said before, you prepare it for retrieval. And if you have the document we saw here, we saw exactly how we are going to collect for the retrieval process, which one to include, which is our intention in this exercise. Yeah. So why this matters? Because the retrieval document include asset ownership, sensitivity classification, lineage and transformation, and live statistics. the system can answer questions like which data set is confidential and who owns it. So without querying raw data or exposing sensitive fields, yeah. So what this delivered avoids is like the black box embeddings, external APIs, LLM hallucination, uncontrolled prompt injection. Its purpose is explainability, not sophistication here. So within the AI ready principle, this exact pattern can later be extended by replacing TF-IDF with embeddings, sorting vector and vector database, filtering document by sensitivity, injecting retrieval document into LLM. And RAG needs curated governed context. Agents need definition and lineage to act safely. Semantic consistency reduces hallucination. So I think that is what we need in here. So just to iterate here, you have this is the code you can run. This is the first part of the code, which is hopefully is not going to have any uh, errors here. And this is, for example, this is the basics one. This is how to go through the path and how to use the path library or the path the import, the one we import, and then we put like the curated data now into that here. And then this is the business glossary we're talking about. So we add the glossary here. So as you can see, customer order and their definition, this one. And also, apart from the glossary, we will do also the registry, which is, yeah. Again, the registry will have two assets here with their sensitivity and source and transform included. And then we need to do like the knowledge, as it were. So hopefully, so this had been, which had been it had been saved into this location in data curated knowledge. Yeah. So if you go to the data curated data, sorry, it's not this. I think it could be data curated, and this is the knowledge base here. So this is the two output here. So the order silver list and the customer, this is the two which had been created. And now the retrievals, this is always been problematic, but let us check whether it is doing it. So it is running. Use the star here. And this is what is coming from this one. So the customer silver and order silver, and this is like the average from there. So in a nutshell, what you've seen now is RAG needs curated and governed context. RAG stands for Retrieval Augmented Generating. Agents need definition plus lineage to act safely, and semantic consistency reduces hallucination. And the context is what turns data into knowledge. So that is for today. Thank you for listening. See you later.